This is a list of the evolution of computing technology and how it's changed over generations in order for something like Bitcoin to exist in the first place. The evolution of technology, how humanity got to Bitcoin, and why it's just the beginning. The first echoes of logic came from Plato, who lived in CE 428–348 BCE. Records of his logic and other Greek thinkers built the embers of the fire of logic and mathematics. Next innovator for this list is William Gilbert, who lived between 1544–1603. He led the discovery of electromagnetism. While not exactly the electromagnetic force as we understand it today, Gilbert's experiments with magnetism in the late 16th century were the earliest foundation for understanding it. He coined the term electricity and recognized that magnetism and static electricity were distinct phenomena, yet related. This helped inspire Hans Christian Ørsted, 1820, discover the link between electricity and magnetism. It is a key discovery which I will share knowledge of. In 1820, Ørsted demonstrated that electricity and magnetism were connected. During an experiment, he noticed that a current of electricity through a wire caused a nearby compass needle to deflect, showing that an electric current could produce a magnetic field. This was the first experimental evidence of electromagnetism, the force we now know to be a unified phenomenon that includes both electricity and magnetism. A question you may have, as I once did, is how did Ørsted get the electricity to run through the wire in this experiment in the first place? Ørsted used a voltaic pile, the first electrical battery, invented by Alessandro Volta in 1800. This early battery consisted of stacked alternating layers of metals, typically zinc and copper, separated by moist materials soaked in an electrolyte, like salt water. The chemical reactions between the metals and the electrolyte caused electrons to build up on one metal, zinc, creating a difference in electric potential. When Ørsted connected a wire between the two metals, the electrons flowed through the wire, creating an electric current. This current generated the magnetic field he observed affecting the compass needle. The next innovator was Isaac Newton, the 1600s. Classical physics, gravity, calculus, showing the universe runs on rules. Newton's discoveries in mathematics inspired later thinkers like Gödel and Turing, who formalized the logic of computability, and Maxwell, who built upon the electromagnetic theory atop Newtonian-style equations, Albert Einstein, 1900s, relativity, pushing science into deeper, abstract thinking. Einstein's approach to science encouraged more rigorous mathematical treatment of abstract concepts, indirectly influencing thinkers like Alan Turing, who formalized the foundations of computer science. In addition, the discovery of energy mass equivalence, ERMC2. This formula deepened our understanding of energy as a physical resource. In Bitcoin's case, energy, in the form of electricity, is the foundational fuel that anchors digital trust and security, proof of work. George Boole, Bertrand Russell, Kurt Gödel, 1800s–1900s, formal logic, Boolean algebra, logic becomes math. Alan Turing, 1930s, computability theory, the Turing machine, foundation of all modern computing. What is a Turing machine? It is a theoretical model that defines what it means for a machine to compute. It's an abstract, hypothetical device that can read symbols, like zeros and ones, write symbols, store information on a tape, which acts like memory, follow a set of rules, a program, to decide what to do next based on what it reads and its current state. What is a Turing machine? It is a theoretical model that defines what it means for a machine to compute. It's an abstract, hypothetical device that can read symbols, like zeros and ones, write symbols, store information on a tape, which acts like memory, follow a set of rules, a program, to decide what to do next based on what it reads and its current state. In a physical computer, this concept translates into circuits and transistors. Reading data means detecting if a transistor or circuit is on or off. Writing data means changing that state, turning the transistor on or off. The computer follows programmed rules, software, to manipulate these on or off signals to perform any computation. Steve Jobs, 1970s-2011, user interface revolution, made computing accessible to the masses in a decentralized and easy-to-use personal computer. Next was Bill Gates, 1970s present. Software for everyone, Microsoft, OS standardization, PC adoption. Satoshi Nakamoto, 2008, Bitcoin, blockchain, decentralized consensus. Computation becomes trustless digital value backed by energy. Bitcoin is not just digital money, it's a milestone in decentralization, removing the need for trusted third parties, energy anchoring. Tying digital truth to real-world energy, proof of work, mathematical finality, code as law, trust through cryptography, digital scarcity. The first time data has value that can't be copied or counterfeited. Global permissionless networks, no gatekeepers. Borderless finance. Bitcoin was not predictable in the 1990s. But its ingredients were visible with tech-fanatic mailing lists, public key cryptography, digital scarcity experiments all taking place during that time period. Likewise, what comes next may already be forming quietly, in research labs, obscure white papers, or anonymous GitHub repos. We can't predict the next invention, but we can map the direction of human intention toward sovereignty, toward trustless systems, toward automation of truth, toward minimizing control and maximizing freedom, toward building better products for humans. Bitcoin is not the end. It's just one of the building blocks in a far larger chain of technological evolution. It is impossible to predict what future things and people could be added to this list thousands of years from now, except that the list will advance.